So one more time, transformation form is the same thing as vertex form. We use these two interchangeably, just like I can call general form standard form, and both of those have the same meaning. The reason that we use it interchangeably with transformation form is this is my AHK form, and later on in the semester we'll study other kinds of functions where we still have an AHK form, but it doesn't have a vertex. That particular shape of function doesn't have a vertex. So we want to make sure that we're using language that can extend beyond just parabolas. What feature on the graph do I want to look for to help me write my transformation form? Vertex. So where is my vertex? 4, 1. Here's my vertex. Is that vertex a maximum or a minimum? That is a maximum. Okay, so what pieces of information do the vertex tell me about my vertex form? Yep, it tells me my h and my k. So h is 4, but when I see it inside the equation, it's going to look like what? Negative 4, because h, when I put it in the equation, that minus sign from the form stays there. So it's always going to be the opposite of where that actually is. All right, so I'm going to write down what we've got so far. I have y equals, I don't know my a, but I do know my h. So you said x minus 4 squared. What else can I do? Plus 1, my k. So I have k right here. I'm just going to kind of label what I've done. And inside the equation is where I see the opposite. We need to find our a value, and there's something I know about the a value already that helps me know the reasonableness of my outcome. It's yes. Is it going to be negative or positive?
Negative.
How do you know?
Because it's reflected over the x-axis.
It's reflected over the x-axis. It opens down. It points down. What can I do to algebraically find my a value? Yeah. We're going to pick one of the other points that's on here, and we're going to do what with that point? We're going to put it in for the x and the y, and then that'll just leave the a, and then I can find it. They've got 2 other points marked for me here. I can grab one of those. Do you guys want to use one of those, or do you want to pick out a different one?
Use one of those.
Use one of those. Do you want to use the 3-0 or the 5-0? 5-0 sounds good. So what do I put in the place of the y? 0, because that's the y part of that ordered pair. Equals a, and then what am I putting in for x? 5 minus 4 squared plus 1. Order of operations says I do my parentheses first, right?
Yes.
All right, so what is 5 minus 4? 1. So I have a 1 right here that I'm going to square. Exponents comes first. Let's see, Daryl in the back, not Daryl in the front, because we've got 2 Daryls. I'm going to have to find a better way of separating you guys verbally. Daryl in the back, what is 1 squared? Try again. Remember, it means multiplying it by itself. 1, yes, because 1 times 1 gives me 1. So I have a times 1. Well, a times 1 is just 1a, yeah, so it's just a. So I have a plus 1 over here. I have 0 over here. What do I do to find a now?
Put the 1 over there.
Put the 1 on the other side. I'm going to subtract it from both sides. And so negative 1 is my a value. Does that make sense with what I see?
Mm-hmm.
Yes. I knew it had to be negative. I didn't know a negative what. Turned out it was a negative 1. But that does make sense. So my transformation form, my vertex form, would be y equals negative 1, or you can just write that as a negative, and then x minus 4. What do I have to do to the parentheses?
Square.
Square them. That's how I know it's quadratic.
Plus 1.
Plus 1, yes. Beautiful, beautiful work. Since we already went through all that trouble to find our a value, the next form, the factored form, is going to be really easy. What feature on the graph do I want to look at for my factored form? Yes, my x values, my roots. Those are the other pieces that they have marked for me. So this right here is a root, and this right here is also a root. The one on the left, 3, 0, what is the x part of that ordered pair? 3. So I would write this as x equals 3, because that's the x part of the ordered pair. How do I use that to find a factor? Set it to 0, so I'm going to minus 3 on both sides. X minus 3 equals 0. Once it's equal to 0, what's on the other side is my factor. I'm going to do the same exact thing with the other root.
X minus 5.
Yes, because I have x equals 5, subtract 5 from both sides, and we get x minus 5 is our other root. You're absolutely correct. So now I'm all ready to write my factored form. What is it going to start with?
Oh, no,
Starts with a -1. Why?
Because negative.
Yeah, a is -1. So you can put a negative sign all by itself, or you can put a -1. It's up to you. Those are both mathematically correct. And then what are the two factors?
X minus 3 and X minus 5.
X minus 3 and x minus 5. Does it matter what order we put those in? Nope, just the same way it doesn't matter whether I do 2 times 5 or 5 times 2 on my calculator. Order there doesn't matter. For my general form, I can't just look at the graph for this one. We have to grab one of these, either transformation form, my vertex form, or my factored form. Which one do you guys want to use? Okay, let's do transformation form. You just, like I said, you just have to grab one of them. So I would have y equals, I've got the negative here, and then x minus 4 squared plus 1. What do you notice this form has that my general form does not have? Parentheses. They both have a squared, but this one has the parentheses. I need to get rid of those parentheses.
So you do X minus 4 times X.
We do x minus 4 times another x minus 4 because we need to get rid of this. So x minus 4 times another x minus 4. This is where my attention is right now. I'm going to bring the other pieces down so that I don't forget them, because if I forget about those other pieces, it'll be wrong. I'm going to use double distribution with the x minus 4 and the x minus 4. So I take x and I multiply it to both pieces. X squared, because remember, when we multiply, that's when my exponent changes. When I add, that's when my coefficient changes. So I have x squared, and then x times -4? -4x. And then I have to take the -4 and distribute that also. -4 times x? -4x. And Sierra, what's -4 times -4? 16. Positive or negative? Positive 16. Thank you, ma'am. That still has to be inside parentheses, because I have to take this -1 that's my a value, and I have to distribute that to everybody. Not to the +1 at the back, though. Why not? Not in the parentheses. And at the beginning of my problem right here, the negative was in front of this, so it's only being multiplied to this, not to that +1 at the back. So I'm going to take that -1, I'm going to distribute it to each piece here so that I can get rid of all the parentheses. -x squared. Yep. Plus 4x plus another 4x minus 16, and then I got to bring down this +1 here. Last step, and then I'm all the way done with this. What do I still need to do, and then I'm done? Combine like terms. So I have a 4x and a 4x here. Yep, that'll be a positive 8x. Anything else to combine? Negative 16 and positive 1. Negative 15. So my general form, I would have y equals what?
Negative x squared plus 8x minus 15.
Yes, negative x squared plus 8x minus 15. Absolutely beautiful, fantastic work, guys. We are going to keep looking at forms today. We're going to answer students' favorite math question, when are we ever going to use this? So we're going to look at some applications. Go to page 84 for me. Page 84 in your book. Elijah, do you need me to go back? Okay. Page 84 in your book. All right. So we're going to have to use some decoding skills as we're doing these story problems. These are going to use all of the mathematical skills that we've built up throughout the course of this unit. But we need to figure out, based on what they ask for, how to go about that. Which form will give me that information? Or how do I get those pieces? So I want to start off just by chunking the words up. How does this question start? First two words. How long? If somebody asks you how long, what do they want to know? It might be the length, it might be the time. Let's read through this and figure out whether we want length or time here. What do you think we're looking for? Length? Length of what? Keep reading. The time, yes. How long will it take? So there's some more key words right there. So they want me to find the time. Which variable in the equation that they gave me do you think means time? T. So this is what I'm looking for. T is the time, and they tell me that they're measuring it in seconds. Do you guys see our function notation over here? This h of t? So the reason that we use function notation is because when we go to graph things, on my graph, I always have an x-axis and a y-axis. Sometimes, like here in story problems, we use variables that make more sense to the context, like t for time and h for height. This function notation tells me which one is my independent variable, which one is my input, which one belongs on the x-axis. That's the part inside the parentheses. The part that's not inside the parentheses, right here, this h, that's telling me that that's my output variable. Output variable on a graph is your y variable, so that would be the up and down part. Does that make sense? We're not going to do anything with these parentheses. They're just telling me that height is the output and time is the input. There's another weird symbol in this equation. This guy back here. What does the h with the little 0 next to it mean? Height. Which height? It's very specific. It's towards the end of the words. The initial height. What does initial mean? The before or the starting, yes. This is our starting height. So that's what they're telling me right here. Okay, so they want me to find time. They gave me an equation. We know what all the pieces of the equation mean now. What do we know about this situation other than we want to know the time? The roof is 400 feet above the ground. And what is happening with the roof? Something's falling off of it, right? And we want to know how long until it does what?
So it hit the ground.
Till it hits the ground. We want to know how long it takes the object to fall. So when will it hit the ground? Is another way of phrasing this question. All right? What would the initial height of our falling object be? 400. So where would I put that in the equation that they gave me? At the end. So I still have this equals negative 16t squared. I have a positive 400 because it's 400 feet up in the air. This h over here is just height. And I want to know when it's going to hit the ground. What would the height be if the object is on the ground? 0. So that's what I was mentioning earlier. When we use this right here, this t in parentheses, this is telling me what my output variable is, but that's what the meaning of this whole thing is. The t in parentheses just says this is your input variable. This is like your x. So they're telling me at the beginning of the problem with the way they wrote this function notation that time is my x variable, my independent variable. I don't actually substitute anything in there. That whole function notation means output. That's a great question, though, because that's a common place where students will get confused. Okay, so the object is on the ground, so I put 0 there. This is our starting height, 400 feet up in the air. T is what we're looking for, so I can't substitute anything in there. What can I do to solve this now? What'd you say? Not yet. We can bring the 400 to the other side. That is something that we can do. So I would subtract 400 from both sides. So I'd have a negative 400 on the left is equal to negative 16t squared. What can I do with it from there? Divide it by, not 16, but you guys are so close. Negative 16, there we go. Be really careful with your signs. Even as a math teacher who's been doing this for years and years and years, sometimes I'll miss a sign and it throws me off. So pay careful attention to that detail. It's really important. Positive 25 is equal to t squared. What kind of an equation are we looking at here? What'd you say? So close. What kind of equation are we looking at? I see this right here. What kind of equation is this? Starts with a Q. Quadratic. Give me a synonym for solution. Roots. X-intercepts. What form do I want this in if I'm looking for the roots to the x-intercepts? Factored form. To put it into factored form, I need it equal to what?
0.
Equal to 0. So let's subtract 25 from both sides. So 0 equals t squared minus 25. I only have 2 terms here. Most of the time when I look at a quadratic equation, I have 3 terms, right? We've got A, B, and C. But I only have 2 right here. Which 2 do I have? Because somebody's missing.
You got C and A.
I have C and I have A. Whenever you see a variable squared, that's your A. Whenever you see a piece with no variables, that's your C. What's going on between them? Subtraction. Does anybody remember what kind of special situation we call it when I have just A and C and it's subtraction in between them? Give me a key word for subtraction that starts with the letter D. Difference. This is a difference of?
Perfect squares.
Yes. Difference of perfect squares. When I factor a difference of perfect squares, I can use a shortcut. I don't have to use the X and the box. I know I'm going to get two factors that are almost completely identical. What will be the only difference between them?
The sign.
The signs. One will get a plus, one will get a minus. How do I decide what goes inside the factors? What do I do to each of these pieces?
Divide.
Close. How do I undo something that's been squared? Not divide by 2, but square root. This will give me the first term in each factor. What is the square root of t squared? T. That goes at the beginning of each factor. Think about when we have factored form and we're putting it into general form and we use double distribution. I would take t and multiply it by t. That gives me t squared. I want to do the same thing to my c value. What's the square root of 25? 5. So that goes at the back of each of these. Once I have my factors, how do I find the solutions from there? Set them each equal to 0. So I have t plus 5 equals 0. I have t minus 5 equals 0. So the one on the left where I have the plus, I would subtract 5 from both sides to get t all by itself. So I get t equals negative 5. For the other one, I would add 5 to both sides. And I get t equals positive 5. Way back here, when we had 25 equals t squared, and Soraya, you said, it's going to be 5, right? And I said, almost. Like, we're really close. If you said t equals 5, you would only have one of these answers, right? You wouldn't have both of these answers. That's why I kind of steered us in a slightly different direction. Because I want to make sure that you guys understand, whatever the highest power is in my equation, in this case it was what was the biggest exponent? Biggest exponent was 2, because it was squared, right? That means there's 2 answers here. Whatever the biggest exponent is, that tells you how many answers there are. So I knew I was looking for 2 answers and not just 1. All right, so I found my 2 answers, but this is a story problem, a context problem. So now I need to make sure that I've answered the question. What was the question again? How long will it take the object to fall? How are they counting time in this problem?
Seconds.
In seconds. So each of these would need the unit of seconds on here. You can't have negative 5 seconds. You're absolutely right. So even though both of these answers are mathematically correct, and in some contexts both answers would work, in this particular situation, because t means time, we can't have negative time. So I would throw this one out because time can't be negative. And so I would have just this one answer here. Do you guys understand why I threw that answer out there? But it's still really important that we found it, because not all situations would have me throw that answer out. I can think of several situations where we would keep a negative answer. Like if we're talking about something diving under the water, we would expect some negatives, right? So just because it's negative in a story problem doesn't mean it's wrong, or doesn't mean that we throw it out. All right. Let's go look at the next problem. Number 2, same page. On number 2, they ask me another question. Look all the way at the end. What do they want to know?
How long is it in the air?
How long is it in the air?
So time.
So time. We want to find our time.
The equation's in general form.
The equation is in general form. T means time. What does the H mean? Height. Question. What piece of information can we pull right from our general form? Our y-intercept. What's the y-intercept here? Yep. Here's my y-intercept. What do you notice about the a value on this? It's negative. So if I was just to draw a real quick picture of this, just so I have something in my mind, I'm not going to be exact, really rough sketch here. I know that on the y-intercept, it's not starting at 0, 0, because it's 5, right? And it has a negative a value. So it's going to be reflected. It's going to look something like this. Bad sketch, but you get the idea, right? I just need to know in my mind what's going on, because that helps me figure out how to set it up. How long is it in the air? Where on this picture is it in the air? All the way until when? Until where?
It's like 10, I don't know how to describe it.
I'm going to trace along this, and you tell me when it hits the ground. What'd you say? At the x-axis right here is where it hits the ground. And all this other space, the ball is in the air. Or it's not a ball. What are we throwing here?
A javelin.
A javelin. Here's where it hits the ground. If I can find that time, then I know it took from here all the way to there. So far, so good? All right. Quick question before we actually set into this. How tall is the person throwing the javelin? We do know. How tall is the person throwing the javelin? No. Look at my graph. Think about you throwing something. Think about when somebody would start and stop a stopwatch. Where would you start the stopwatch at? At the beginning, right? Here's where the javelin is at the beginning.
So about 5 foot.
5 feet. That's our y-intercept. Starting height, or height of the person. Well, and then also think, you don't throw it from the top of your head, right? You throw it from about here. Starting height, 5 feet. 0, 5. Love it. All right, I want to find where it hits the ground. What do we call that feature of a graph? A root, or we could also call it what? An x-intercept, or a solution. What form would help me find a root? Factored form. Factored form to find roots. Looking at this picture, I know something about my roots already. Since it started in the air, if I were to sketch in the rest of this parabola, it would be back here, right?
So it'll be negative.
It's going to be a negative. We're going to find one answer that doesn't make sense in our context because it'll be a negative time, and then we're going to find a positive time. All right, so I want to look at this equation that they gave me. If it's on the ground, what's the height? 0. So instead of h of t, I'm going to put a 0 in there. Because again, this means on the ground. I want to put this into factored form. How do we take it from general form and put it into factored form? What tools do I want to use to help me do this?
Order of operations.
We're going to use some order of operations. What form do I want again? Factored form. So I need to go through the process of factoring.
So first we'll find GCF.
We're going to look for a GCF first. Yes. Yep. 16, 79, and 5 don't have anything in common, but what's in front of the 16? Negative. I do want to take that out. So my GCF is just a -1. I can't divide it by anything else, but I can take that out of each piece. If your A value is ever a negative, you want to get that out. And because 1 can go into everything, I can take it out of each piece. All right, so I would have a negative out in the front. And what would I have left over? Positive 16t squared. What's it going to do to my 79t?
Negative 79T.
-79t. And what about the 5?
Negative 5.
-5. Here's my A value after I got the GCF out. Can I use my shortcut?
No.
No shortcut. That makes me sad, but that's okay. So if I can't use the shortcut, I need both the X and the area model. I'm going to put that over here since I've got more room over here. So there's my area model. Here's my big X. Which pieces can I put inside the box right now? A and C. So I've got 16t squared and -5. On my X, I'm going to take the A and the C and multiply them together. So I'm going to take 16 times -5, -80. So I need two numbers that'll multiply together to give me -80, but when I take those same two numbers and I add them, I get my B term, which is -79. -80 and 1. So I'm going to have -80t and a +1t inside my box. If you guys get messed up with different variables and you put x's in there, I'm not going to take off points for that. I tend to get confused about that too. Hi, Floyd. Welcome, welcome. All right, so now just 2 boxes at a time. I'm going to start with the easy ones and we'll save the hard one for the end. So right here is where I'm looking first. -5 goes into both of those. How did you know it had to be a negative? Leading coefficient right here, what it's touching is a negative, so I have to pull that negative out. Correct. Both variables don't have a t, so I don't take the t out of both of them. Now I'm going to come up here. 16t squared and 1t. What will go into both of those? 1t. So I can just take a t out there. So there's one of my factors. Then I'm going to go vertically, and again, I'm going to do the easy one first. So I'm over here, 1t and -5. What will go into both of those? +1. What did you say, Lauren?
I didn't know if we were going this way or this way. Depending on S.
This way? Yeah. So I'm looking at these two, and I always write the piece up on top. All right, so I saved the hard one for the end. 8 can go into both of them. I need to make sure it's the biggest. Here's something I can use if I wait until the end for the hardest one. Remember, whatever is here gets multiplied to this to give me this. 16. Is that the only thing that goes into both of them? They both also have what? T. 16t. Again, if there's two that you're looking at and you're stuck on it, skip the hard one. And then at the end, you can say, okay, this times this would have to give me that. So what would my missing piece have to be? All right, so we've got our factors. I know that I have 0 equals negative sign out in front, t minus 5, and 16t plus 1. So here's my factored form. How do I find the roots or the solutions from here? If I double distribute, I'm going to end up back here.
You said it equal to 0.
Yes, we're going to take them and set them equal to 0. Anything that has a variable with it. Do I need to take the negative and set it equal to 0? Nope, there's no variable there. T minus 5 gets set equal to 0. Yep, 16t plus 1 equals 0. So I would add 5 to both sides. I get that t equals 5.
So what is 16 plus t plus 1 be our output?
Yeah, because what are we going to do to both sides here?
Would you minus 1?
We would minus 1 from both sides.
Division?
Then do division. And what do you notice about that root? That solution?
It's a this,
It's going to be a decimal. Not just a decimal,
a fraction,
a fraction. What kind of fraction?
a negative,
A negative fraction. What does t mean again?
time,
Time. Measured in what?
seconds.
Measured in seconds. Do both of these make sense?
No.
No, can't have negative time. So I'm going to throw this one out, not because we did anything wrong, but because in this situation, that answer doesn't make sense. So 5 seconds is how long it's in the air. All right. You guys have one last homework assignment for this unit, looking at some applications like this. All right? As you guys are working on that tonight, if you get confused in the language, you're like, I don't know what form will help me figure this out, send me messages. Because we've talked a lot about forms. I don't want you guys to leave things blank just because you can't translate it from the words into what form we would want. We will start studying for your test tomorrow in class, and that's when I'll give you your review. Your test is this Friday. So tomorrow and Thursday to study, this Friday for your test. Have a good one, everybody.